Verifying trig identities. There are times in higher mathematics when we have a complicated trig expression that needs to be simplified in order to work with it. So we're going to learn how to use trigonometric identities to change an expression to a simpler form. So for this lesson, we'll be using these identities. And it will be helpful to have these in front of you as you go through this video. So either jot them down, or if you have my notes, have that in front of you, because I'll keep referring back to these, and it would just be good that you could see them. So there are 3 boxes there with all different identities in them, and we'll make use of those in just a minute. When you're working with these identities, the following strategies are useful. First, see if what's in front of you is in one of these boxes, and that you can change what you have to what it equals according to these identities. The second strategy, and the one that gets used the most, is to change everything to sines and cosines. If it already is a sine or a cosine, you wouldn't change it. A third strategy that sometimes comes up is to factor, and another strategy is to combine fractions. So go through these strategies, look at each one and see if you can do it, and then after the next step, start over again, look at all the strategies, see if there's one that you can apply. To verify that the equations are identities. To do these problems, we want to change the left side and the right side separately by using the identities, and then when the left side looks like the right side, we're finished. So when we look at cosine x, cosecant x equals cotangent x, using our strategies, we ask ourselves, is this expression one of the identities in those boxes? And it's not. So the next strategy is to change everything to sines and cosines. First, we already have a cosine x, so we'll just leave it. If it's already a sine or a cosine, leave it alone. And then from our identities, we know that cosecant is 1 over sine equals, and then also from the identities, we know from the quotient identities, we know that cotangent is cosine over sine. Cotangent is also 1 over tangent, but that's not changing things to sines and cosines. We want to pick the identity that changes things to sines and cosines. So cotangent is cosine over sine. Now, if we combine fractions, on the left side, multiplying the top and bottom, we have cosine x over sine x, and that's also what the right side has. As soon as the left side equals the right side, you're finished. So we're instructed. The next one is cotangent of negative x, secant x equals negative cosecant x. We can find cotangent negative x in the odd-even identities. Cotangent negative x equals negative cotangent x. And then I'll just recopy everything else. Okay, nothing else in front of me is in the identities boxes, so we'll change everything to sines and cosines. We have our negative, and then cotangent is cosine over sine. Secant is 1 over cosine equals, and then negative, and cosecant is 1 over sine. Then, looking at our fractions on the left side, the cosines would cancel, and so I'm left on top with a negative 1, on the bottom with sine, which is the same thing that I have on the right side, so it's finished. One thing that makes these problems difficult is that they're all different, and there's no step-by-step way to work through them like many other math problems. Really, it just takes practice. The more of them you do, the more you figure out the little tricks, and the clearer it becomes what you should do next. But it really just takes practice. Cosecant x minus cosecant x cosine squared x equals sine x. None of these things is in the list of identities. If we look at our list of strategies, one of them is to factor. Since cosecant x appears in both terms on the left, we can factor that out. We can divide out cosecant x. So cosecant x parentheses, and then if I divide cosecant by cosecant, that's just 1 minus, and then dividing it out of the second term just leaves cosine squared. Now, one trick that comes up quite a bit is in the Pythagorean identities, we have cosine squared theta plus sine squared theta equals 1. You can rearrange that. If I subtract cosine squared from both sides, I have sine squared equals 1 minus cosine squared. Or if I subtracted sine squared from both sides, I would have cosine squared equals 1 minus sine squared. These rearranged forms of that Pythagorean identity come up quite a bit. And look, see, we have 1 minus cosine squared, which we know equals sine squared. If you can make something in a more simple form, that's what you want to do. So I still have cosecant, and I can change 1 minus cosine squared into sine squared. So I've dealt with the factoring, I've dealt with my identity sheet. Now, the next thing would be to change everything to sines and cosines. Cosecant is 1 over sine times sine squared equals sine. And on the left side, I can cancel the bottom sine into one of the top ones, and I just have sine x on the left, sine x on the right, so it's finished. Secant minus cosine equals tangent sine. Nothing on the identities list, so let's change everything to sines and cosines. Secant is 1 over cosine, and then if it already is a cosine, leave it alone. Tangent is sine over cosine. Again, tangent is 1 over cotangent, but that's not changing things to sines and cosines. Now, one of the strategies is to combine fractions. On the left side, we are subtracting fractions. And when you subtract fractions, you need a common denominator. So I have a denominator of cosine and a denominator of 1. The common denominator would be cosine. So if I put a cosine on the bottom of that second fraction, I have to also put a cosine on the top. That gives me across the top 1 minus cosine squared, and on the bottom I just have cosine. On the right side, when I multiply my fractions, the top would become sine squared and the bottom cosine. The top of the left fraction is one of the rearranged Pythagorean identities that I showed you just a couple of problems ago. 1 minus cosine squared is equal to sine squared from the Pythagorean identities. And now, since the left side looks like the right side, we're finished. For this one, the only strategy that applies here is changing everything to sines and cosines. So on top, cotangent becomes cosine over sine. Tangent is sine over cosine. And then secant is 1 over cosine. On the top, the cosines would cancel, the sines would cancel. If everything cancels, it's not just blank, there's a 1. So I have 1 over cosine. Remember, fraction bars mean divide. So if I want to unstack that fraction, that's 1 divided by 1 over cosine. And the rule when you divide fractions is to flip and multiply. So that's really 1 times cosine over 1. Now, it's obvious that this is finished, but technically it's not finished until the left side looks like the right side, and it doesn't because we have those 1s. So you want to write one more step. Cosine equals cosine, and now it's done. Looking at the identities, in the Pythagorean identities, 1 minus tangent squared is equal to secant squared, and that's a more simple form, so we want to use that. So cosine squared, and then 1 plus tangent squared is secant squared, equals 1. Now change everything to sines and cosines, so cosine squared, and then secant is 1 over cosine. And since it's secant squared, it's 1 over cosine squared. The cosine squareds cancel, 1 equals 1, and that one's finished. Cosine t, cotangent t equals 1 minus sine squared t over sine t. If it is annoying or confusing to you to have the t's, you could use an x or a theta or anything you want where those t's are. So on the left side, there's nothing to do but change everything to sines and cosines. Cosine t, and then cotangent is cosine over sine. On the right side at the top, we see that rearranged Pythagorean identity again. 1 minus sine squared is cosine squared. Now on the left side, if you put together the fractions, multiply tops, and you have cosine squared, multiply bottoms, and you have sine, and then it's the same thing on the right. So that one's finished. Secant squared over tangent equals secant cosecant. Even though secant squared equals 1 plus tangent squared, that would make it more complicated. You only want to use the identities if it makes it more simple. So let's not use that, and let's change everything to sines and cosines. Secant is 1 over cosine, so secant squared is 1 over cosine squared. And then tangent is sine over cosine. On the right side, secant is 1 over cosine, and cosecant is 1 over sine. Now remember that the fraction bar means divide, so let's unstack those fractions. 1 over cosine squared divided by sine over cosine. On the right side, if I multiply the fractions, I have 1 over cosine sine. The rule for dividing fractions is to flip and multiply. So that would be 1 over cosine squared times cosine over sine. Then on the left side, 1 cosine could cancel. And so combining across the top is a 1, across the bottom is cosine sine. Same thing on the right side. So that one's finished. And we're just going to do one more. Cotangent squared over cosecant equals cosecant minus sine. Okay, there's nothing really that makes that more simple if we use the identities, so let's change everything to sines and cosines. Cotangent is cosine over sine. Since it's cotangent squared, it's cosine squared over sine squared. And then cosecant is 1 over sine. On the right side, cosecant again is 1 over sine minus sine. On the left side, we have division, so let's unstack the fractions. Cosine squared over sine squared divided by 1 over sine. And you can skip that step if you can kind of do that in your head. On the right side, though, I'm subtracting. If you're subtracting fractions, you have to have a common denominator, and it would be sine. So if I put sine on the bottom, I have to also put sine on the top. So the right side becomes 1 minus sine squared over sine. Okay, back to the left side, I have division of fractions, so I need to flip and multiply. Cosine squared over sine squared times sine over 1. right side can just stay the same. Then I can cancel out one of the signs, and I have cosine squared over sine equals, and then on the right side, 1 minus sine squared is also cosine squared, and then it's finished. Often these types of problems can be done in more than one correct way. Some people really catch on to these and are able to quickly find shortcuts. If you can do this correctly, that's fine with me.